engine, the internal combustion engine, what we call it ICE.
Yes. Internal combustion engines, yeah.
So combined with electric motors. So they together to drive the wheels. And if you want to have a non-range with EV mode, with a purely driving EV or electricity, usually we'll have a big capacity for the batteries. So that's the reason when we see the HEV and the PHEV, they have different size of the batteries, right?
Yes.
Usually the plug-in PHEV, they have a bigger capacity of the batteries. I mean the traction batteries, the power batteries. Because usually in our traditional cars, you have a small 12V batteries in front of the truck or in the back for the low voltage instruments.
Or inside the engine most of the time.
Yeah, usually in engine trunk, they have a 12V batteries.
Battery, yeah.
But the battery we are talking about in the EV, usually we are calling the high voltage battery, or the traction battery, or the power battery. So that is the high voltage battery. It's different compared to the 12V low voltage batteries in the traditional cars. So for new energy vehicles, for NEVs, some of the cars still have the 12V batteries, the small batteries.
In the HEVs, that's in the BEVs.
In the EV or HEV, some type of car still keep the 12V batteries, the low voltage batteries, to running the 12V instrument. But
To low voltage
the
equipment.
low voltage,
Okay, I wanted to ask that.
yeah.
We have a massive traction battery at the back. Then now we have another 12 volt, the old type of 12 volts in front. So I was like, is it really for starting? So I was trying to wonder what it was about.
Yeah, maybe we can go over and have sometimes. Maybe something more
Clearly. I think the AC also is a bit loud.
So yeah. So what's your question?
Yeah.
Or yeah, we can give you a question. I mean, you.
So what I'm trying to ask is, what's the primary function, primarily, of that low voltage 12 volt battery that is now also inside the hood of EVs? Now that we have a large battery bank.
For the entertainment systems, for the low voltage systems. So in the EV, we still have the low voltage instrument. Equipment facilities.
Yes.
We still have the low voltage equipment or facilities in the EV. So that is using the electric from the 12V low voltage batteries.
Sorry. So in any case, the traction battery is an HV battery. It's a high voltage battery.
Yes, it's high voltage battery, and it's DC directly.
Yes.
Comes. Also, the low voltage battery is also DC, right?
They are all DC, yes.
12V DC. Right?
Yes.
So the 12V DC is using for the facilities or equipment that don't need that too much power. Yeah, less power.
And it's just that's why they are low voltage equipment.
That's one of the reason that's why they use low voltage. And the traction battery or the HV batteries are using for the facilities that need more powers, more kilowatts powers. Since,
like the motors,
like the motors,
the traction motors,
like other like the air conditions. Now the air conditions are also using the high voltage.
Oh.
Yeah, and also the heaters, the heaters in EVs, they are all using the high voltage cables.
I believe the same with the power steering too, because I noticed yesterday when we went to 2 days ago when we went to do car inspection. I was looking to pick up one of they had a pickup. I realized that it did not have a power steering pump.
Power steering, yeah.
Yeah, so the steering rack was 100% electric, no pump.
Yes.
So I think that also would be an HV equipment, because I don't think the small batteries can.
Yes. That's correct. So in EV cars, many facility equipment can be used because in the traditional situations, there's no high voltage cables. You know, in the gasoline cars, you can only use the low voltage.
Yes.
So
everything is low voltage.
Everything is low voltage. But in EVs, everything can get into the high voltage to use more power to use more functions, to use more powers. So that's the reason why when you're using the air conditioner, you have to open the engine with the traditional cars.
Yes.
You don't have
because
to
the alternator needs to help to recharge the battery.
Yeah.
Right? The alternators is in the engine to help to charge the battery to stay alive.
Yes.
That's why you have to on the engine.
Yes.
It runs the alternator.
That's the reason.
But in this case, because the battery bank is big.
Yes, because battery packs have storage a lot of high power electricities.
Oh, yeah.
So it can be a power bank to power other facilities or equipment that need the electricity. So we can see from the pictures that is the very basic equipment need for the hybrid drives. So the yellow one is the battery, the HV batteries, or we can call it
traction batteries.
Traction batteries.
Yeah.
That is the power bank. That's the power from. It can be storage the electricity. Also, to output to discharge the voltage. And here is another one is called DC-DC converter. So what is a DC-DC? DC-DC is, DC is direct current.
Correct, yeah.
Direct current. So DC-DC converters means just transform the DC to another DC, different frequency, from the high voltage DC to a low voltage DC.
Good. So that means.
Yeah. So you can see here. Here is the low voltage battery.
12 volts. The other one is maybe 750.
Yeah.
Depending on the voltage of the high voltage battery.
Yeah. So this is, you can see, is converted the high voltage to the low voltage. Transform voltage. This is.
Now that includes charging the battery also.
Charging the battery.
Yes, that
charging the low voltage battery.
Yes.
Yeah. So that's a good question. So if, for example, if you have a traditional cars, ICE cars.
Yes.
If you didn't drive it for 1 month, park there for 1 month, maybe your battery will die.
Yes.
Maybe next time you have to recharge the battery.
To discharge and maybe die completely.
So, but for EVs, this is no problem. because the ECU will detect the battery voltage of the small batteries. If it finds maybe less than, for example, 90% or 80%, the high voltage HV batteries will automatically charge the high voltage, the low voltage batteries. So it will help to recharge the low voltage batteries. So you will never concern about the low voltage batteries because the system will automatically help you to recharge the low voltage battery from the HV battery. From the HV batteries.
But in this case, sorry, just to ask. In this case, I'm thinking, why does the HV battery stay longer and not discharge?
Why the HV battery stay longer?
Let's say I park my EV car for like a month or 2 months, and I travel, I came back, and I can still start and it's speaking. Yeah, because of the noise. That one is not right. Okay, last one.
Yeah, that is
all right. So how are you able to? How is it able to retain its cell integrity after such a long time of say isolated period of say 2 months, and I come back and the system is still active and working? What's the secret? What's the reason for that?
What's the reason for
the battery not draining, not running out, not discharging?
the HV?
Yes, the HV batteries.
First, the capacity of the HV battery is much bigger, much bigger capacities. So usually we have maybe at least 60 kilowatts.
Okay.
60 to 150 kilowatts. So it's a lot of electricity.
Yes.
If you want to dry the electricity, you need to play hard to drive all this electricity.
Yes.
And the second reason is the HV battery, they have a BMS. It's called the
battery management system.
The battery management system will connect it 24 hours to detect will detect the battery's situations. So whenever the battery is low, they will tell you to recharge the HV batteries.
That also comes to play when we do the battery ESS for in solar systems. Yes, the battery management handles all that.
That's true.
Because for us, before we got into lithium-ion batteries, we used the gel batteries like this type. So, but we realized that the batteries could drain if we don't do something about it. So, what we used usually then was what they call the battery equalizers. If it is more than 1 or 2, it just keeps the voltage at an equal rate.
Yeah.
So if they're going to drain, it will limit. So the battery equalizer can isolate.
Yes, that we call the battery balance.
Yes.
Battery balance.
Yes.
So that's the same in the EVs. So if you want to change a new battery cells, you have to do the battery rebalance to keep all the batteries in the same voltage. Because it's just like I would say a cup or maybe a wood cup.
Yes.
That if some of the cup is too short, and then the water will liquid.
Yes.
So you have to keep the cup on the same levels. So that's the same reason. You have to do the battery
battery balance. Okay.
Battery balance.
So okay, I get it. So you talked about is it ECU or ICU for? I didn't pick that line. You mentioned something about the ECU.
ECU, yeah. Well, there's ECU there's a lot of ECU in the EV too. So for the batteries, it's called BMS, yeah, battery management system. For the motor, also have its own ECUs. Own ECUs. Uh-huh.
What's ECU?
Sorry, yeah, a lot of ECU. Sorry,
What's the meaning of ECU?
ECU is mean the electric control unit.
Oh, yes, yes.
Yeah. And one more thing is that usually the battery management systems is also integrated inside the HV batteries.
Yes.
And the BMS systems, the battery management systems, need the 12 V voltage from the low voltage batteries.
To start?
Yeah, to start to generating
Oh,
to generating
okay.
the BMS working, to keep the BMS working.
So that's another thing. That's another point. You see, because when you talked about the DC to DC converter, my head is a bit hazy about it. I needed to at least have a bit of the technology or the mechanism of operation, how it works. Now, I need a 12 volt low voltage battery for all the 12 volt systems.
Yeah.
Now, I also need that 12 volt. That is through the converter now, DC-DC converter, to send signals to the traction batteries to pick up.
Yeah. Yes.
So what happens if my 12 volt battery is low?
As I said, when the 12 voltage battery is low, the HV battery will charge it.
Okay.
So if there is one situation that the HV battery also low, and it cannot recharge the 12 V voltage, then the car will dead. I mean, you have to
Get an external car charger.
yeah, you get a car charger to recharge the 12 V batteries. Then the 12 V batteries give the power to the BMS, and the BMS give the signal to the HV battery and to recharge outside the HV batteries. Then come back.
Oh,
So this is different compared to the traditional cars.
I understand.
Yeah.
And so this is nice to me. Now,
Yeah.
this is a clearer picture for how EV works.
Yes.
I have thought about that part. I read a few things about this stuff. My mind has been working on this 12 volt battery for a very long time.
Yeah.
So I've been wondering, what exactly is this 12 volt battery doing here? For the first time, I'm understanding clearly.
So you understand? Okay.
Yes.
Okay, so
I get it.
yeah. So that's the reason. I mean, you have to always keep your HV battery have the electricity. You don't want to go to zero. Usually for EVs, we recommend when the battery capacity is 20%, you have to recharge it to charge it.
So
20% to 80% is a healthy range, healthy for the batteries, for the HV batteries.
for traction batteries.
For traction batteries. So as an EV driver, we don't recommend you to full charge 100%. It's not healthy for the battery's life. And also we also don't recommend to run out of the electricity to zero. Usually 20% we recommend you to charge, and don't full charge to 80%, at least 90%. Don't charge to 100% every time.
So now
it will help you to
extend the life.
Extend the life of the batteries. But if you want to do a long range, I mean on highway, then you can charge to 100%. If you are only doing the city traffic,
20 to 80.
20 to 80 is the
So battery efficiency will be like 60% in this case.
yeah.
And the depth of discharge, like you said, shouldn't be beyond, that's DOD, should not exceed 20.
Yeah, that
Yes,
just
that's
recommend
80% DOD, yeah.
to charge for this. That means you cannot do 100% because the car, I mean, it's a tool. It's not a, I mean, you don't treasure it at the, I would say, as a guard. It's just a tool for you. So 20% to 80% is just recommend charging charging capacities for daily use. And if you want to do long range, then don't care. 100% to 0%, it's okay too. But it's better to use it from 20% to 80%. It's a recommended capacity, charging capacity for the healthy of the batteries.
Very clear. I wanted to know why the overcharging for the short range movement, like from office to the house, market and the shops, just around.
Yeah.
If you're doing like normal pull.
Yeah.
in the
So for
neighborhood.
example, my Volkswagen ID4, the EV, it's usually 550 kilometers per charge, 0 to 100%, 550 kilometers, and usually I only charge it to 90%. And then when the battery comes to 20%, I will
Charge again.
charge again. So about 70% capacity of percentage of the capacities. And for this 70% capacities, I usually can doing maybe 350, 300 to 350 kilometers. I can use for this this capacity of the batteries. So it's enough for me for a week daily transportations.
That's
Yeah, because
350.
you can my round trip for my daily walk is around 40 kilometers. 40 kilometers. 40 kilometers is around maybe 10% of my batteries. 10%. So 70% it can do seven round trip for my daily trip. So it's enough for me to
move
recharge
around.
it again from 20% to 90% 1 week.
And like 8 days or 9 days in some cases.
8 days or 9 days.
Yes,
per
yes.
day. Per day.
Yes, per charge.
Then maybe you can you will charge it for 3 days. So
Apparently.
apparently, yeah. But it's just theoretically. Because if you want to you don't want to charge this frequently, then maybe you can charge to 100% and then to 0%. But that is not good for your battery. Yes.
It could destroy, like you said, of course. I knew that already from working with working with batteries for home use. I understand that we don't really, well, we do 100% charge, but not always up to 100% because it's always being used by a charger.
Yeah.
But the minimum we set it different voltages. For example, if I was using a 48 volt system, I want to see how many volts is the full charge, maybe 57 at the highest charge. That's for lithium ion battery. 48 volt for the traditional battery is about 52.1 volts. Each of the cell is about 3.2 times 16 is 52.1. So 51.2, sorry. But when it's fully charged, it gets to 57, thereabout. When it's fully drained, it comes to 46, 44. So, but I'm asking myself, I'm not going to allow, because 100%, 0% means it's now say 42. It's not healthy for the battery because the cell contracts. There's traction issues on the cell. So what we do, we set at maybe 46. That's like 20% left. Depth of discharge now will be like 80% that you are used. So at that 80%, we set it on the inverter for the battery to cut off as though it is now zero. But what we are protecting is the health of the battery. So it does not exceed, say, 46. The inverter sees 47, 46. By the time it's going less than 46, it beeps and the whole system shuts down. And they have to wait for an alternative source of charging, maybe from the solar or from the grid, before they can use again. That way, for the next 3 years, 4 years, 5 years, 6 years, 7, 8 years, the battery is still healthy. But if you just leave it and say, no, let it drain to zero, when you drain to zero, all these cells does not come back 100%. If the battery drains from 100 to zero, about in every what do you call it? From every, they call it circle of charge. From every circle, some cells dies from the battery.
Yeah.
But after like 2 or 3 years, you get maybe like 70%, 80% efficiency because the cells are dying each time it ran to zero. So we put a stop gap, say somewhere around for a 48 volt low voltage, we put a stop gap for somewhere around 47 volts. So it works from 47 volt to 57 volts, and that's 80% usage. But I'm not really used to this upper side, like when you said don't charge more than 80%, then don't discharge more than 20%.
Yeah. Okay. Yeah. Okay. So here's another things for the HV, the hybrid electric drive is the internal chargers, or we can call OBC. It's called the onboard charger. Onboard charger. So the onboard charger can, uh, you know, for many EVs, they can use fast charge and slow charge, right?
Yeah.
Fast charge is just DC to DC, high voltage charger to high voltage to the HV batteries. And the slow charge is using this internal charger, or it's called OBC, onboard charger, to transform the DC to AC. Oh, sorry, to transform the AC to DC to the batteries, to the HV batteries. So I will show you, because my car, my EV, right now is using the slow charge on the ground parking garage. I will show you when we finish this slide. The onboard charge OBC will help you to transform the AC, the slow charge AC to the DC to the high to the HV batteries.
Okay, so in this case, um, it is the charging station that decides whether it is AC or DC.
Sorry?
It is the charging station that decides, right?
Yeah.
Whether it's AC. I mean, what's the difference between? How will I know an AC charger or a DC charger?
How you mean how to recognize the slow the AC charge?
Yes.
So okay. Maybe we can directly go to the to the. So you see here. Here's the DC, the DC charging. So this is for fast charge. And come down here.
Sorry, let me get my phone. So this is a DC charger, fast charger.
Yeah, this is fast charger, and here is the slow charger. And this is for
AC charger.
This is AC.
Slow charger.
Yeah, AC, and that is DC. Different.
But sometimes you have the two of them here.
Yeah, sometimes beside.
Yes, I noticed. I noticed. Wow. So this is.
Yeah, we can leave it. We can leave it.
Okay, okay.
Okay.
So now the charging station would now determine.
So you can find when we change back to this cameras, and you can find that uh, the hybrid EV didn't have our OBC onboard charger or the internal charger, right? You cannot find an onboard charger OBC.
I need it.
You find OBC?
No.
If you find a plug-in, you can find a onboard charger.
Yes.
Yeah, OBC, right?
That's for the hybrid.
Yeah, because you have the charge port, right?
Okay.
But for HEV, you can't find an OBC onboard charger, right?
So the onboard charger is actually like a converter or something.
Convert, yeah, I can convert it to transform from the AC to DC. Transform the outside AC to inside DC for the batteries.
And
So
that's
the reason why
that's only when
you have a charging port outside. When you have a charging port, charge port. Because in this case for HEVs, you don't have an outside charge port. You cannot charge from outside. You can only using the engine be an electric generator to charge the batteries. You cannot charge it from outside. So you don't need a OBC onboard charger.
apparently the battery is also very small.
Yeah, that's correct. OBC. OBC is onboard charger. Onboard charger, OBC. Or you can call it internal charger. Onboard charger. Onboard charger.
It also does about the same work with the alternator from the conventional systems.
Sorry?
That's almost like the same work with the conventional old type of internal combustion systems. Yeah, that's what the alternator does for the battery, the 12-volt batteries. The 12-volt battery is like an internal charger that charges the alternator charges the 12-volt battery in the old kind of cars for gasoline cars, internal combustion cars. No, I mean for ICEs, internal combustion engine, we have alternator, 12-volt alternator
Yeah.
that turns on the belt
Yeah.
to charge the battery.
Yes.
So this OBC is more like that for these new kind of traction batteries.
Even the
Is
OBC.
it? And
The OBC.
I'm asking, is it the same thing or what's the primary use for OBC?
No, OBC is only using for the outside. You mean when we're using the slow charge to charging the cars, charging the batteries. It's AC. It's AC, maybe 7 kilowatts.
Oh yeah.
AC. And the battery, the HV battery, they are using DCs. The HV battery is using high voltage DC, right? The traction battery is using high voltage DC, high voltage DCs. So you cannot charge from AC directly to AC, right? You have to convert from AC
into DC
into DC
using the converter, which is an
using
OBC.
the OBC.
So this is like the charge controller in a way that controls the charging. When it's fully charged, the OBC will also close the valve.
Yes, yes, yes.
Charge, no, no charging.
Okay. And another one is the motor, the electric motor, right? The generator, the motor.
Yes.
And you can see from here the IC and clutch coupling and the motors. They are on this on this same line.
Yes. Yes.
Uh-huh. Okay. And the inverter. What do you know what is the inverter?
Exactly. We haven't really talked about that. I was looking forward to. Yes.
So the inverter, yeah, is also transform the because the motor using
Electric.
electric, and the motor is using usually they using you can see three
Three
cables.
phase. Yes.
So it's a three-phase motors. So it's ACs. So it's using ACs.
So that's where the combination happens.
Yeah.
Because already without the inverter and the power coming in from the traction or battery systems, the ICE is already by itself
Yeah.
turning
Yes.
as a mechanical engine. So it turns from the clutch to turn the. Is the clutch? Is this clutch? Is it also gearbox?
Gearbox?
No, no, it's not.
No.
So from the clutch, it turns the motor already. Then, if the clutch isn't working, then there's a three-phase side to this same electric motor.
Yeah. To directly rolling the
So that's where the combination happens.
yeah. So the inverter
I can understand why the inverter is there because the inverter is the one that actually brings the power. Actually, I am thinking now that's another converter because from the traction HV batteries to that inverter is DC, but from the inverter to this electric motor is AC because this motor is AC.
yeah.
Otherwise, it won't have a three-phase system. And really, you cannot. I think it's so. So this motor is an AC motor. This electric motor
Electric motor,
is
yeah.
an AC motor. Oh, but is it the same with? Is it the same with 100% electric?
Sorry?
The the BEV, is this the same thing with? Is it also electric motor? Does it have this kind of system?
Yeah, we can change back to
Yeah. I wanted to check. Okay. All right. Let's see. I really can't see that diagram here. Anyway, this is just an open diagram. That SLD gives us a better, the single line diagram that we're looking at just now gives us a better view of this. Okay, this is still on the hybrid.
Yeah.
The
Hybrid.
this to DC converter. The inverter is not showing here anyway. The transmission, auxiliary battery. Okay.
Okay, maybe in these pictures we didn't show it the inverter because sometimes it's combined in with other equipment. Okay.
No, but I think can we if we can. This is what we're looking at, the hybrid system. Yeah. Okay, but the inverter is not showing.
Inverter. Not sure. Yeah.
Okay, so this diagram is even clearly shown. It's an SLD, so it will give you a very clear picture. If I have an SLD, if we have an SLD for the battery energy system, I think it's easier to also see what kind of combination the electric motor would be. Because my question really is for the BEVs, is the motors still AC, electric AC motors for the 100% electric vehicles? Is this motors, this electric motor, is it still three phase? Most likely yes.
You mean for BV?
Yes.
So it depends.
Okay.
So it depends. It depends. So because some of the BVs they are using
DC motors.
DC motor and some is using AC motors. Like maybe some circumstances they are using both in one car.
Oh, really?
In the front they're using AC. In the back using DC motors. So it depends. It depends.
Wow, that must be an SUV or a flying car. Because that car would fly.
So the picture showing here is a three-phase AC models. So
Clearly seen.
So that is need the inverters. That is need the inverters. Okay. Clear? to the next slide. Okay.
Okay.
And some questions. So in this schematical, which two components can drive the vehicles? Which two components can drive them?
The combustion in the ICE and then the ICE and the electric motors in this case.
So this one, this one.
Internal combustion engine, yes.
The first one.
The boat.
The,
That's the first one, yes.
this one. Okay. Yeah, that's right. So they are using internal IC and also the electric motors.
That's why it's combined hybrid.
Yeah, that's the reason that it means combined. Okay. Second, what does the Ford hybrid means?
Combination.
Yeah, combination. Yeah. Okay. And in these pictures, which components were added in addition to the internal combustion engines? Which component was added compared to the ICE engine?
I think the whole items on the roll,
Yeah.
all.
Yeah.
Yeah, because from the, what do you call it? From the internal combustion engine is not electric motor, it's a mechanical motor.
Yeah.
So in fact, that's a gearbox, not even a
Yeah, all five is
yes, all five is added, yes.
in this
All five is
situation.
added, yes.
And please find these components in the pictures.
I have to come there.
Yeah, you can come. You can come. Yeah, sure. You can come, please.
Okay, so this is the DC-DC conductor, this is the voltage battery, this is the inverter, this is the motors, this is the IC, this is the traction battery,
Yes, correct.
internal charger.
Yes, yes, correct. Okay.
So this internal charger in this case also the what do you call it?
OBC.
OBC.
OBC, yeah. Onboard charging, yeah. OBC. Okay, next is which components connected and disconnected the internal combustion engine from the electric motors?
Is it flywheel?
Sorry?
Is it flywheel?
That's your answer?
I was looking for that flywheel, but that's the one they call clutch here, clutch coupling.
Sorry?
Which component which component disconnect the no, sorry, I didn't get it. Which component disconnects the internal combustion engine? I see, from the electric motor. Oh, it's the clutch coupling. So sorry.
Yeah.
Yes.
Yeah,
I didn't get the answer. I didn't get the questions right.
yeah, it's the
Clutch coupling, yes. Because if that one is isolated, everything is now 100% electric.
Yes.
But if the electric needs if the IC needs to engage, it engages through that. But in those days they used to call it flywheel.
Drivers, yeah.
Yes, in the old cars. But it's also the same thing as clutch.
Yeah.
Yes.
Okay, so this is clutch coupling.
Yes.
And this is a hybrid vehicle powertrain. You can see overview and electric motor and HV batteries and motor. DC converter charging system.
Okay. So that's the battery at the back.
Yeah. for all cars, especially in the beginning, we need to find the right location of each part, each equipment in the cars.
Because different cars will have different locations.
Yes, different car, different location, but almost in the same
Areas.
areas.
Circles.
Same area, same.
Okay. Close.
And now we can try again to find the
Component in real time, because this one now is no longer a diagram.
try.
This is now
The inverter.
okay. So at least I remember this as the OBC.
Yes, obviously.
This is the traction battery.
Yeah, the traction batteries.
Well, this is the electric motor.
Yes, traction motors.
Okay, so there are two things. So I know this is the battery.
Yeah, the traction batteries.
Is that the I think that's a business.
Yeah, you can. Did you recognize the cable?
Yes.
Cable. You can
This
actually
cable,
find the
yes.
cable connected to which two things. You can try to learn from the cable's direction.
Okay, so now, all right, that's good. This is even better. Because this one brings us to this.
Yeah.
But the auxiliary battery is not. So I couldn't know which one is this. But this is even better.
Yeah.
This is the auxiliary battery, right?
Yeah.
Ah, so
Yes. Yes. So
Okay.
you can learn from the nice direction of
yes.
the
So I get it.
yeah. So this is
This is oh, this is the front. This is the back.
Yeah.
This is the back wheel drive.
Yeah.
I didn't think about that.
Yeah.
So I didn't the inverter. This is the traction battery.
Yeah. The DC converter. The battery batteries. Yeah.
And then of course the motors.
Yes, that's right. Yeah. Okay.
So that's a back wheel drive.
Sorry?
That's a back wheel drive, so it's easy.
Yeah. So this is a hybrid drive systems. Usually have this component. Usually have this component. The place may be different, but every time you see the cables connecting, you can know what is this is for.
Oh, is this the phone?
Yeah.
Because now there is a what you call an asphalt from there to this place. So this is more likely for this is the drive.
Yeah.
Drive is the car.
Yeah. This is front. This is the rear.
This is the front drive.
But I don't see
Okay, that's true. So this is the front. It's front to
It's
drive.
railway. Front engine rail drive. Yes. Front engine rail drive.
But this is the drive. The drive is coming all the way to this.
Yeah. Yes.
20 minutes.
Yeah.
If you want to also link the back to the is just put the drive on the back.
Okay.
Yes. This is perfect. It's easy for me to see like this.
Okay. Excellent. The capacity of the battery is very large, so the vehicle can run entirely on electricity. So what components are involved when running on electric power only?
The capacity of the battery is very large, so the vehicle can run entirely on electric. What components are involved when running electric?
Power only, or EV power only, electric power only. What components?
Wow, that's a hard one.
Don't worry.
No, so I know that the transmission,
Uh-huh.
okay, is a transmission
So
because
when we finish this lesson, this question, we can take a break.
no, 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 no. This part, this is the part where you also need to put your mind to work. So now the transmission is
Get more
electric.
coffee to refresh.
The transmission is electric. The ICE is not electric. I do not know what the differential is yet. The clutch works for the ICE, is not electric. The drive shaft. Okay, so those two parts I don't know. Oh yes, that's the shaft that turns. No, that one works for the boat. By the way, the shaft is to work for the both side. So I feel the answer will be the transmission, because the transmission now in this case, if I'm right, the transmission in this case is electric motor. If it is, then that means that's the only thing that's working.
So
The answer will be transmission.
only transmission.
Yes.
Well. No, yeah,
But the other two, I don't know what they are.
This is not the only answer. I mean, this is optional. I mean, multiple options.
Options, okay.
Not only the transmission. You can choose more if you think it's right.
Okay, so now I think that's where. Well, it is not ICE. Which components are involved running the electric power only? Oh. Okay, I did not get the questions right. So the transmission is working, the drive shaft is working, the clutch is certainly working. Then the last two ICEs is not working because that's mechanical. But the differential is where I don't have a very clear. I don't know what is differential.
Differential means so for two sides wheels, the speed is different. So you need the differential to give the different speed for the wheels. That is the differential.
Is that also like a gearbox?
Sorry.
Is that also like the gearbox for the old type?
Well, it's different compared to it's gears, but it's different compared to the gearbox.
Is that also a component?
Also, what?
The differential, is it also a component that can be seen?
Yeah, differential also have differential in the traditional cars, and in the traditional cars. Or other teachers.
Okay.
那边什么时候去那个文化馆？现在就让他把门通知学生去把它开着吧。
可以啊，可以啊。我们待会讲完学校就可以过去。
要的，
我可以讲。
要的，好。等一下，你是先到文化馆去，还是先你说有问题再去交流去？
你待会还要去相应是吧？
我应该没问题，没问题。那就先到文化馆。好，反正我家好。行，那你的有事在外面叫我。
So maybe I need a bit of an explanation on what the differential is. What is the differential? In particular, what is the work of that differential?
Let me show you pictures. This is differentials. This is the differentials. I don't know if you know this kind of system.
This is a speed selector, right?
Differential. This is the differential. Let me see. Okay.
So the differential is working. That thing is gearbox. In the automatic, the old type of cars, that could be gearbox. Why in the electric cars it should be called?
Yeah.
Oh, okay. Okay.
So this is the differential in the cars. Differential.
This is gearbox.
It's a gearbox, but it's a differential gearbox.
Yes.
It's different.
So it's different from the IC kind of motors. No, does the IC have its own differential?
Yeah, they have differential too.
It's different from the differential from the electric cars.
I think it's the same. It's the same type of differentials.
Okay, okay, okay.
Yeah, these are differentials. These are differentials.
And usually in these new car kind of cars, it's seamless. You don't get to know when it's moving from one to the other. The differential in ICEs, do they use oil?
I think so.
Just no, not ICE. Oh, ICE uses oil. I'm talking about the differentials in electric cars.
Electric cars. Uh-huh. I think they need oil too. Uh-huh. I think every gears they have to need some kind of oil to lubricate the systems. Uh-huh.
I wanted to be sure of that.
Yeah. Okay, so
So this differential, sorry, is coupled with the motors, the drive the motors. Is it coupled together with the motor?
I think this
The location.
the location. Okay, I think this differential is here. Is located here.
Okay, okay,
In the real traction drive shaft. Yeah.
okay, okay,
Here,
okay.
here. It's
All right.
not covered with the
Okay, okay.
motors.
That means this one is electric then.
Uh-huh.
Yep.
You want to take a tea break, coffee break?
Okay.
Yeah, let's take a tea.